Good morning, everyone. Today we are going to start the chapter number 9, that is object oriented testing. These are the contents from the chapter number 9, object oriented testing strategies, test case design for object oriented software, and interclass test case design. First, we will see the introductory part regarding the software testing. Software testing, it is a method to check whether the actual software product matches expected requirements and to ensure that software product is defect free. Here software testing means it is a method for checking the actual software product that matches the expected requirements. Whenever we are going to develop any software, we are having that requirements, so that expected outputs after executing that system, what output we will get, to check that output with the our requirements. If that requirements are matched, then that software product is defect free. That is software testing, means we are going to test the software based on the requirements. It involves execution of software components using manual or automated tools to evaluate one or more properties of interest. So we can test the software manually or using automated tools. The purpose of software testing is to identify errors, gaps, or missing requirements in contrast to actual requirements. So your testing is the process of finding the differences between the expected behavior specified by the system models and the observed behavior of the implemented system. That is testing. So the proper software testing produces some benefits like high quality software products we will get after proper software testing, then satisfaction of the customer. If customer is satisfied with their requirements, then after successful software testing, and at the end we will get the satisfaction from the customer. Then lower maintenance cost, accurate and reliable result. Accurate and reliable result in case of that, if we are able to, that system is matches with the requirement, or delivers the output as per our requirement, then system gives the accurate result and it is reliable. So these are the benefits that we will get after the proper software testing. Then different kinds of non-conformance. Here the testing process is helpful for finding a non-conformance which gives an error. So here it is a difference between the measured value and the specified value. Error is the difference between the error value and, sorry, the measured value and the specified value. If we are specifying any value and we will get the different value, then that is error. So there are three types of errors are there, like syntax error, logical error, and runtime error. So here syntax error means if we are using the improper code for writing program, then that is syntax error. Here proper code is very important from writing the code. Here if for example, if you write void main instead of void main in C or C++ programming, then there is syntax error. So this is somewhat language error, like there is a special tool in which it corrects the syntax error. Okay, so syntax error, that is we have to write the proper program. Okay, then next one is logical error. So logical error means this is the different kind of error, like if there is a mistake between logic, if it is a mistake between logic, and then this kind of error generates if we are calculating the multiplication and we are using this symbol for multiplication as a plus sign, then that is logical error, and we are expecting the multiplication output as output and we are performing the additions. Okay, so this kind of errors are the logical errors. We are missed with the logic. So if we compare this error with the syntax error, then it is noticeable that if syntax error is generates, then program cannot compiles or runs. But if the logical error is occur, then program runs and compiles as well, and it will give the incorrect output. If we are having that syntax error, then program is not executing. If there is a logical error, program is going to compile and it gives the output, but that output is incorrect. Then the next error is runtime error. So here this kind of error is generated after the execution of program. That means at the time of program is in running mode. Whenever we are going to run that program, at the runtime that error is occurred. So there are so many reasons so that runtime error is occur, like our runtime errors are array out of bound error, divide by zero, then floating point error. So this type of errors are runtime errors. Like uh, then fault, it is an incorrect step, that is process or data definition. Then the failure. So these are the different kinds of errors, that is syntax error, logical error, and runtime error. The next point is, what is the need of testing? Yeah, testing is necessary because to achieve the quality in software products, to achieve the quality of software products, yeah, software testing is necessary because we all make mistakes. In general, some of those mistakes are unimportant, but some of them are very expensive or dangerous in case of that quality of that particular software. So we need to check everything and anything we are going to produce, because things can always go wrong, like human makes mistakes all the time. In case of we are considering as a software product, we need quality product. So it may be possible that there are some mistakes, it will be happen, there are some mistakes will be happen by the tester or by the human. A software testing is very important because testing is really required to point out the defects and errors that were made during the development phase. Whenever we are going to test any particular software, it is necessary to find out the defects and the errors from that development phase. It is very important to ensure the quality of the product. To ensure the quality of the product, software testing is necessary. So another reason is that testing clarifies the user requirements. It tries to meet the user satisfaction. It verifies the interaction and integration of components. That's why testing is necessary. Then see the workflow of testing. Here, first we are having the plain test. Then we are going to design the test cases for that. Then we have to implement the test. Either we can use the manual testing or you can use the automated tools for the testing. So we have to evaluate the test cases and we are getting the results and at the end. And we have to execute the integration test. So there are some types of testing like unit testing, integration testing, system testing. So we have to execute that. Integration testing means we have to execute all the module we have to test. Then we have to execute the system test. Here these are the different types of testing here. Then object oriented testing. Here object oriented software differs a lot from traditional procedural software in terms of analysis, design, and coding techniques. So testing object oriented application also ultimately differs than testing applications developed by traditional techniques. So it's because in traditional code coverage test, it is wrongly interpreted that object-oriented code is 100% tested. When in fact only 50% is covered. Whenever we are going to use inheritance or we are having one base class and two derived classes, here in that derived classes only 50% of the data is tested, and at the base class all the data is tested. So using traditional metrics, only 50% of inherited methods, that is from the derived classes, only 50% of the methods are tested in each derived class. But in the base class, all the methods are tested here. That means 100% testing in at the base class, and in the derived classes only 50% of testing is there in traditional approach. So here, whenever we are going to create any large scale systems or design, or we are creating any large scale system, that object oriented testing is done rather than conventional testing. So here, object oriented programming is different from the conventional. So the whole object oriented testing revolves around the fundamental entities, that is known as class. So with the help of that class concept, larger systems can be divided into small systems. It is well defined units which may be then implemented separately. That means we are going to create separate modules for that system. So the object oriented testing can be classified like conventional systems. They are called as level 4 testings. There are different levels for the testing in object oriented testing. There are some issues in object oriented testing, like object oriented programs have no sequential procedural execution. No sequential procedural execution. Object oriented programs have no functional decomposition. Then the approach of object oriented testing doesn't use structural chart to design integration testing. So that object oriented testing must test the parameters for the analysis and design models, then coding techniques. There are different issues in object oriented testing, like we have to specify the product requirements long before testing commence, for example like portability, maintainability, usability. Then understand the users of the software with the use cases. Then develop a testing plan that emphasizes like rapid cycle testing, get quick feedback from that a series of small incremental tests. Then we have to build the robust software that is designed to test itself, user assertion, exception handling, and automated testing tools like JUnit is one of the automated testing tool. And we have to conduct the formal technical reviews to assess test strategies and test cases. These are the some issues in object-oriented testing. So we have to follow the parameters for object-oriented testing is object-oriented analysis and object-oriented design models. Then coding techniques, which what coding techniques we are going to use. Then next one is testing object-oriented analysis and design. So your object-oriented testing evaluates object-oriented analysis models. That means here see the example for use case diagrams. Object-oriented testing evaluates analysis model for the object oriented analysis model like use case diagrams, and for the design model class and sequence diagram. Your object oriented testing also performs walkthroughs, design prototypes, formal technical reviews to test the correctness and the consistency of the designs. Your walkthrough means tester has to tester have to go through all the test cases, then validations. Tester has to design some prototypes, some it has to take some conduct some formal technical reviews to test the correctness and the consistency of the design with the requirements. Then object oriented analysis and design testing. Object oriented design testing verifies the syntactic correctness and semantic correctness and consistency. So these are the parameters based on that object oriented analysis and design testing are verified. So here analysis and design models cannot be tested in the conventional sense. So because they cannot be executed, we cannot execute the analysis and design models in test in software testing. So your formal technical review can be used to examine the correctness and consistency of both analysis and design models. By technical review, we can examine, or the tester can examine that correctness and consistency of the analysis phase and design models. So you see the correctness. Correctness means it is syntactic or the semantic. Here, first one is syntax. Here, each model is reviewed to ensure that proper modeling conventional have been maintained. That is like UML notations are, we have to see that UML notations are used correctly or not. Then the semantic means it must be judged based on the model's conformance to the real world problem domain by domain experts. That is, does that UML design captures all the classes and operations and they are understandable or not? Then next one is consistency. Here, a design that representation in one part, but it is not reflected in the other portions of the design in an inconsistent design model. That is how that consistency is maintainable. Consistency is going to be maintained in the at the testing phase, so that it may be judged by considering the relationship among entities in the model. So here each class and its connections to other classes should be examined. The class responsibility collaboration model and object relationship diagram can be used in the consistency. So these are the testing of object oriented analysis and design. We have to verify that analysis and design models. So the next point is testing object-oriented program code. So there are various approaches to test an object-oriented application code like unit testing, integration testing, and system testing, which are performed at the various phases of object-oriented application development. The phases are like requirement specification, preliminary design, detailed design, then coding, then in the testing phase, unit testing, integration testing, and system testing. Here in the requirement specification, all the requirements from the customer is mentioned, and we have to verify that requirements with the software product at the we have to verify that requirements, that what output we are getting is match with that requirement or not. Then preliminary design, then the preliminary design means the prototype. Before developing that software product, we are going to create one design, then detailed design, then we are going to implement this, we are going to code that system. After coding phase, then we have to test that software product. That is, we are going to perform unit testing, integration testing, and software testing, sorry, system testing. Their unit testing means we are going to test the classes of that software or that product. Then integration testing, we are going to test all the modules one by one. We are going to test the module. Then system testing means we test using the use cases. We are going to verify that, or we are going to test that use cases for the system. Here all the approaches of that software, these are the approaches of software or that object oriented testing. Here you can see the phases like unit testing, integration testing, and system testing. This is the object oriented application testing model or the approaches to test the software. Okay, so that's it for today's session. We will stop here. Thank you.